Now another nice brief follow-up word from our sponsor, which is me, because this is a one-man show. Now, in the last video we talked about what happens when you have a change in a particular variable or variables. In this case it was x and y, rise over run, slope and all that jazz. As a particular value goes to 0, this is how the notation looks in proper calculus form. Didn't want to cram it in because I try to keep these videos within about 5 or 6 minutes. You remember how we talked about slope? So we had one value of y where we added a little bit, so x plus h squared, and then x squared, which was basically from the curve y equals x squared. So there's one value of y with a little bit added on, then another value of y with nothing added on. We talked about how it changes as this value add-on h goes to 0. This is how we write it in proper calculus notation. We would say that all of this hits a definite value or a limit, L-I-M, which is short for limit. Get it? Lim-it. Limit as h approaches 0. Let me write that really big so you can see. So we're talking about the limit as h approaches 0. Now, it doesn't have to approach 0. You could say as any variable approaches a particular value. Could approach infinity. Could approach negative infinity. Could approach 3. Could approach 3 pi over 2 or whatever you like. The idea is that it ended up hitting a particular threshold, and this whole function here, which is this limit, do it this way. The limit of this function here as this variable h within the function approaches a particular value, in this case 0. And we also talked about how the function in that particular case happens to equal change in y, or delta y, d for short, as x also changes. Now it also happens that you could even take the second derivative, which is the change of this with respect to x. And we end up with something that looks like this. First derivative was dy by dx. First change in y over the first change in x. As we take the change of this first change here, the change in the first derivative, again with respect to x, we end up with something that looks like this. D dy, or the change in y with respect to x a second time. And this simplifies to d squared y over dx squared. This is known as the second derivative of calculus. What this means in real world terms, for example, if you have a changing variable, we might talk about, for example, how fast you're going. The change in distance over the change in time. We could also talk about, that of course is speed, change in distance over change in time. We could also talk about how your speed changes, so the change of the change. More on this in another video. After all, that's why I like to keep these videos bite-sized so nobody gets indigestion.